MicroID is a door access control company. Since we are dealing with doors, with some added logic, the doors will become interlocking system. Therefore, today we are going to discuss on MicroID interlocking system using our own smart IO board, where a smart board does a lot just for an IO. Smart IO board, previously known as IO board, but this board is able to do so much that we had to add the word smart to it. With 4 inputs and 5 relay outputs, we are able to do multiple things or functions using this input and outputs. So without wasting any time, let's look into the functions, the list of functions that we have. Remember, we don't just sell hardwares. We sell solutions in the form of functions. So the basic list where we have 2-door interlocks, 4-door interlocks, multi-door interlocks, basic IO, panic button, timer, time schedule sounder, and the board is able to accept wireless, peer-to-peer and RF. The board is also able to communicate to each other in peer-to-peer. So if you want to know more about the peer-to-peer and wireless, you can go look into our previous videos on smart converters. It will explain you in details on that. So this peer-to-peer is MicroID's standard of communication, wireless communications. Okay, but today's topic, we will only emphasize on only a certain functions of it. So today's discussions, we are only going to emphasize on the interlocking system. So the interlocking systems we have is the 2-door, 4-door interlocks and multi-door interlocks. At the same time, today we will be introducing to you the first time our latest interlocking board as well. So that one will cover that in our end of the slide, and what is the capability of that interlocking also we will explain to you. Introduction to interlock. Sit back guys and enjoy watching the following video. Let's see how to enter into a clean room. First you enter the changing room, you change into a clean clothes, then you enter the air shower room, then at last only that you can able to enter into the clean room. Okay, this is another clean room. As you can see, they're pressing the push button to releasing the door to the air shower, and they enter the air shower. Then once it's done, then only they open the exit door itself. What is door interlock system? From the video we can understand, it is a security mechanism that prevents access through a door until a certain condition is met. The system locks the door until the condition is fulfilled, and it ensures that multiple doors cannot be opened at the same time, providing added security and safety. Usually, these are used in clean rooms, cargo, changing rooms, crowd control, linen chutes or dirty laundry chute, rubbish chute, prison cells, zoo animal cage, and etc. These are the few examples that I can give, but there are many use cases along with it itself. 2-door interlock pass-through. Today's functions, the first functions we will be discussing on this matter is the 2-door interlock pass-through. There is no such thing as 1-door interlock pass-through, okay? Because for interlock to happen, you need to have more than 1 door. That is, minimum of 2 doors is to be there for the interlock to work, or the system to be applicable. 1 door is already access control, guys. So from 2-door, you can have 3, 4, 5, 6, and as many as you want, okay? But the most basic as minimum easily can be explained is using 2 doors. So in this example, these illustrations, we have 2 different doors, and one is at the left and one is at the right. So we are simulating as if it's a room where they have 2 front door and the back door. Okay, so right now the condition has been set as any side of the door can be used. That means a person can come from the left, from the front and or maybe from the back. Okay, they can come through either way. Any doors they can be used. Okay, so it is currently in the ideal condition, the both doors is able to be accessed. Let's say for this example, a person comes to the front door and opens the door. The moment the person opens the front door, as you can see that the back door cannot be used. So the back door has been in lock condition right now. So no one will be able to come through the back door, okay, until the front door is closed. So once the person goes in and close the door, and the back door is able to be used, okay, and as you can see that the front door is still in the lock condition. So there is a buffer state where the front door will be kept as closed. So no one will be able to use the front door until the buffer time ends. So that means even the person from inside tries to go back, it will not be able to go back. Okay? The only way the person can do is pass through the back door. So once the person passes through the back door, then it's called a successful pass through. All right. So after the back door is closed, the system becomes back to normal. So this is not only applies from the front door to the back door, is also the system works as from the back door to the front door. So either way, the person is able to do an interlock pass through from either direction as well. So two-door interlock, initially the both doors are in lock condition. Okay. So you can open the door by using a push button or added access control. Since this IO board has 4 inputs, which we'll be using for 2 door sensors and 2 push buttons, whether it's push button or access control input. So you can trigger the relay to open the door. And how long the relay can be set? We can set it between 1 second to 180 minutes. And so is the buffer time as well. We can set it to 1 second to 180 minutes. So it's up to you where in the configurations you are independent to set it. So with that, our previous examples, our basic interlocking system has been explained. Okay, so that was the gist of it. Anything to do with interlock is got to do with that. Is one door opens, all the other doors close, and simple as that. Now let's go into technical details in every one of the process. Okay, to look into what else functions that this board can offer. Okay, in compared to the normal interlocking systems, what this interlocking board can offer. So let's start with our two-door interlock explanation. Before we go into it, okay, we have something known as what is called door closed. Okay, where the door sensor detects door closed, we have this sign here say closed. When the door is open, the door sensor says that it's open. Okay, and we added another one more called unlocked state, where the EM lock is unlocked. Okay, and lock state, where the EM lock is in lock condition. So as you can see that normally all the doors are closed, but you will have an EM lock there which is locking the door itself. So in our cases we are using a lock here which indicates as the EM lock. And this green light and red light indicates as the indicator, where we can the door is in idle and usable condition, or is the door is in what is called the unusable condition. So we say that cannot be used. Okay, so this is our jargon words that we will be using in our next slides, so that it will be easier for us to explain the process of the interlocking is taking place. So two-door interlock side, where the both doors are in closed time, okay, and the EM lock is in the lock condition, and we have a push button here which indicates as those are the ones where we're going to use to open the door. Right. So when the person presses the push button, okay, As you can see, the first door, the EM locks unlocks. Okay, so this door is able to be used. But the moment the EM locks unlocks, the second door becomes lock condition. As you can see, the red light here indicates that it says that this door cannot be used. Okay, so the EM lock remains locked and the push button becomes unable to be used. So the moment the person opens the first door, the other side remains, okay, remains locked. So even the person tries to press the push button to open the second door, the door will be still remains locked. So this is how a system works, okay, with the push button and door opening conditions. So the IO board has an additional feature where our fifth relay will be used as an indicator relay. So it's able to indicate whether the door can be used or cannot be used. So that will indicate whether the light is green or red. At the same time, it also will be indicate another condition called the fault state condition, which is not supposed to happen, but just in case, if we do so, we have an indication for that purpose as well. So the fifth relay can show the active state. So in that case, in the fifth relay will be a green light, okay, showing there as the both doors are in idle condition. Okay, the moment one of the doors is open or the push button has been pressed, the light changes to red. That is called the inactive state. For some reason, which not supposed to happen, if the both doors is open, then it becomes in the false state where the green and red light will be switching with pulse, green, red, green, red, green, red. So they'll be pulsing one after one. This will indicate for us that something has gone wrong. Okay? So this is not supposed to happen, but just in case, if it does, we have a warning sign. With two-door interlock function, we already have a better understanding of how an interlock works. So let's see how we can achieve four-door interlock system. As you can see, since the IO board have 4 inputs, by making all the inputs as door sensors, we are able to make it into a 4-door interlock. First, let's look into a normally open condition of the 4-door interlock. Normally open condition, all the doors are initially unlocked. There is no need for push button or access control for this system. As I mentioned earlier, normally open condition means all the doors EM are unlocked condition, where you can open any door straight. At any moment you open any one door, all the other doors EM will be locked and will not allow anyone to use the door. Four-door normally open interlock system is our most commonly used interlock. It is very simple to configure, where all the doors are unlocked condition. Moment any one door is open, the rest of it will be locked. So let's move on to our next interlock system. Our next function is 4-door interlock, but normally closed condition, where all the doors EM lock are in lock condition. Okay? The EM lock are all locked. So you may ask, IO board only have 4 inputs, okay, which is right now is used as door sensors. So how do we unlock the door? So the way we can unlock the door is where we will be using, okay, where we will be using our wireless reader or wireless RF. Okay, they will be able to trigger the door to be unlocked. Okay, so this is a 2-part incident where we use IO board plus a wireless system. As I mentioned, normally closed is where all the doors are in lock condition. For this example, let's use a wireless reader to interact with the door. So when a valid signal is sent, the door will be unlocked. So now the corresponding door can be opened. Smart I/O board accepts the RF as remote to open the door. We can get off-the-shelf 433 MHz RF remotes, and here are some examples of the remotes. Using microID's wireless smart converter, you can use the I/O board as an access control with interlock function. Smart converter can support up to 2500 users. And this wireless is more secure with AES 128 encryption than the 433 RF remote. Well, in 4-door interlock, also we have fifth relay as the light indication, where it have active state, inactive state, false state. False state is when two or more doors are open. Okay guys, we have come to our final function for the interlock system, multi-door interlock. But let's first watch the following video. Let's see what is linen chute or rubbish chute all about. In tall buildings such as hotels, condos, apartments, they have a location where they can throw rubbish or dirty clothes. These are called chutes. So interlock can be used to make sure one chute is open at a time. So falling objects from above floor will not injure the person opening the chutes on the lower floor. Since there are more than 4 floors in a tall building, we use multi-door interlock to lock all the chutes door. You add multiple I/O boards that can communicate with each other to make it a multi-door locking system. Multi-doors are used when more interlock doors are needed than the board itself can support. So we use multiple boards where they can communicate with each other to achieve this scenario. Interlock Gen 2. The demand for interlock was a lot. So we built a new interlock board that can do many extra logics as well. And the board is also customizable to any scenario that is needed. This unique board overcame most of all the limitations the I/O board have. By increasing the inputs to 10 and having 2 dedicated loops for multi-door communication, the board has evolved from the simple I/O board. So therefore we named it as Interlock Gen 2. The 10 inputs has been divided as 4 dedicated input trigger for push button inputs or access control inputs, and 4 dedicated door sensors for the door sensor inputs, and 2 dedicated master inputs, which can be configured as either master release or master lock, and 4 relay outputs for the doors, and 1 relay for indication or alarm. The indication is for the light indication. So the multi-doors is the same concept of the I/O board's multi-door communication. Okay? So in this chart here on the left, as you can see that how the matrix configuration can be configured. It's so versatile that you can choose how the interlocking works.